Hello everyone, welcome to my channel. My name is Malachandra Jain. I am super excited to bring my very fast video. Okay, today topic is very important, angular momentum in quantum mechanics. Let's start with basic some idea. In classical physics, angular momentum is defined by I write first heading. Classical physics we know L equals to R cross P. What is the meaning of this? Here R is the position and P is momentum. We know or no. This quantity tell us how much rotational motion an object has. Right here. What is the meaning of this quantity tell us how the rotational motion an object has. It's so and it depends on how far the object is from center and how fast it's moving. Simply, what is the meaning of the meaning is very simple. But it is depends on how far the object is from the center and how far it is moving. Center, how far is object, how far see object is here, how far is object and how far is moving. This is position vector, this is momentum, and we know this is theta, this is r cos theta, and this is r sin theta. L equals to r cross p means r p sin theta. If theta is 90, then L is max. L max theta 0, L min. Here or no? This is the simple concept of in classical mechanics of angular momentum. Okay, let's study about the quantum mechanics. How quantum mechanics tell angular momentum. In quantum mechanics, angular momentum become an operator. Its action wave function. This is basic lecture of quantum mechanics. Okay, this is the angular momentum. Yeah, L is what this operator action wave function. receding angular. Okay. Let's study about briefly angular momentum. What is the angular momentum and how it behave, how this is operator behave. Okay. In angular momentum have three components: Lx, Ly, and Lj. Okay. This this is I, J, and K. We know cross product and dot product. I cross J equal to K. I dot I equal to what? 1. I cross I. This is I. Okay, this is equals to 0. Because of A cross B equals to AB sin theta and A dot B equals to AB cos theta. Okay. What is Lx? Lx equals to, we write Lx equal to what? X. This is X. This is Y. This is Z. This is the simple formula. Take it. L. X equals to Y P Z minus Z P Y. Sim. This is simple. Similarly, Ly equals to Y. See, Y, then Z P X minus X P Z. Simple. This is very simple form. LZ X P Y minus Y P X. So then so what is the momentum and position operator? Okay, we can write momentum operator equals to P of X. That's P. What is the P? Now minus I H cut del. What is the del? Del equals to, we know del equals to I dy dx plus j cap dy dy plus z cap dy dz. Okay. So similarly, we can write P of x equals to I h cut d by dx, Py equals to I h cut d by dy. There is minus one, sorry. That equals to minus I h cut d by dz. Okay. And if I put this px, py, and pz formula in lx, then my lx formula is plus I h cut y d by dz minus z d by dy ly equals to minus I h cut z dy dx minus x dy dz. Simple. Put this formula in place of px, py and pz and get it. Lz equals to minus I h cut x dy minus y dx. Here the differential operator that come from rotational symmetry of space. Okay, these are differential operator. Simple. Differential. This is what? This is the differential formula. So this is called differential operator. Okay. These are differential operator that comes from rotational symmetry of space. So last I introduce one the most important Hermitian operator. What is the Hermitian operator? Hermitian operator means that we know Hermitian in classes. What Hermitian operator? I put a heading here. Hermitian operator. These have real eigen value. We know in class. What is the Hermitian operator? Now, these are real eigen value. This is also right. Hermitian operator means all observable quantity in quantum mechanics like position, momentum, angular momentum are represented by Hermitian operator. Means they have real eigenvalue. Understand? Example. Put here example. Example. What? Now position, angular momentum are represented by Hermitian operator. Why? This is a real eigenvalue and observable quantity. Observable quantity means we can observe in lab. Angular momentum is something we can measure in lab and it is a Hermitian operator. Okay, means here what Hermitian operator all quantities. Okay, and this is a real eigenvalue, which means that true measure are real number. Real eigenvalue means what? number. Okay. And next class we'll briefly discuss about Hermitian operator and some problem of a Hermitian operator. Okay. Let's study about angular momentum next. You know Lx, Ly and Lz. And all are vector this L equal to Lx I cap plus Ly j cap plus Lz k cap, and L square equals to Lx square plus Ly square plus Lz square. We know the vector. This is magnitude now. Okay. Next, next I tell about commutation relation. Okay. Okay. What is the commutation relation? Relation of position and momentum. How? So how this we get this one? We put it psi because of we operate no? Operate. This is differential of then a b a d by dx plus b da by dx. Good differential formula. Okay. D psi by dx psi constant plus iota h cut x d okay. It's cut to psi. Dx by dx is equal to 1. Minus plus cancel out. There is x px of psi at h cut psi. We get x px equals to iota h. Understand? Okay. Then x py what? This is 0 because of we know the uncertainty formula. Uh, we can measure x and momentum in x, not y. Okay. The x, y, z are mutual commute and px, py, pz are also mutual commute. Can measure same coordinate. No, same coordinate. And position. Okay. Similarly, y p y z p z also equals to attach cut. Next is commutation relation in angular momentum. Relation momentum. Lx ly. What is the commutation relation? What is the commutation relation? Lx ly. Is the commutation relation? First we know what is the formula, then control the formula of x, y, d by dz minus z d by dy. This is x, y, z, y, z dy dz dx, sorry, x dy dz. Okay, commit simply right here. Okay, sorry, minus I have to common. Okay, let's pfx. Their formula z minus z of y z p of x minus x p of z I p z z p x minus y p z x p z. Local rates and comprehensive population. Simplicity. Y p z in z, we know that is px. Y p z in x is pz Z P Y Z P X plus Z P Y X Z. We know this is valid. This is 0. This is 0. And this also is 0. Result is what I P X is iota H cut. Iota H cut R R cross P equals to L. This is LZ. Clear? This is the very simple formula. And similarly, you can write here X, Y, Z. It becomes LX, LY. This is iota H cut LZ. X, Y, that is Z. C. Y, Z, this is X. Z, X is equals to iota H cut LY. And also you can reverse. What reverse? Ly, Lx minus iota H cut LZ. Y, X, Z. Okay. Similarly, you can write also this. And here I want to do some question. Okay. Question is X E up Y equals to how we know 0. Okay. I'll be doing some tips. Position commute with angular momentum. So we get what uh, first sign iota H cut position. Here is the tips and I'm doing some problem. yeah, angular momentum and position, angular momentum. Okay. First, I write it that it is some problem. X commute with L square. What do say? X L square what? Lx square plus Ly square plus Lz square. Okay. X X square plus X Ly square plus X Lz square. Okay. X Lx is Lz. Here I type it's got Lx X. Okay. That is doing some problem. Okay. What is the commutation relation of Lx Lz? I know X Lz minus Lz X X Lz what F X Y. This is commutate this is a 0 minus X Y P of X Y X F X equals to that's what This is the result. Okay, x z. Listen, if I commute position and angular momentum, I get sine into iota h cut into position. Okay, p x in ly iota h cut lz x y z x y we get z x z minus of l by. Okay, okay. This is y. So y l z I get I h cut x cap z l x is equals to I h cut l. Sorry, y. This is k. Okay, this is called. This is the rotation formula. Okay, rotation formula means we. Okay, okay. Sorry, sorry. Okay, okay. And next class, we study about briefly some angular momentum question and commutation relation of J and ladder operator. What is the ladder operator and anything else? Okay, मिलते हैं नेक्स्ट क्लास में टाटा बाय बाय